Hey there, beautiful morning. Um, got quite a few things I'd like to go over with y'all. Um, I am actually scratching my last upload. It didn't work last night as I lost connectivity. Uh, and I want to let you know the COVID reality as an educator is rough, and it's also rough for you as a student, and I recognize that. However, it's going to take all of us, and I just want to ensure that you get the most you can out of this class, but that's going to take both rolling with the punches and a level of trust that the information that I'm giving you is both unique and valuable. And I think for the most of you, you recognize that. But it's really important that you try to stay up with the course material. And if it's feeling like too much, you have to let me know, because to me, honestly, it doesn't feel like this is that much work. And you know, to a large degree, I have already kind of toned down what would normally be required in the class. So to kind of put this in plain words, I think that there is a overwhelming philosophy from me where your success in the class is not based upon the numerical grade that you receive, but rather your zest or passion for the subject matter. And to be honest with you, I feel like many of you are just kind of checking the box. And while I understand that, especially in these frustrating times, it's kind of easy just to close those neurological cognitive pathways and just kind of get it done and get it over with. It is my desire to see you get really psyched and ask really pertinent questions and get on the same page so that we can function as a community. So I hope I don't come across as too harsh, but truly recognize that it is out of a respect for my class, my craft, and also a respect for you. So I wanted to take a moment and talk about compasses. I hope that you all can find a compass. This is my compass that I use. It's a Silva Ranger, and I think it costs probably $50, but that is not what you need for a compass. If you're really liking this, then I think you can, purchase some items that are perhaps a little more expensive if you're going to use them in the future. But you don't need this. You can just get a regular orienteering compass for probably $15 or less, or hopefully you already have one. And the names you want to look out for are like Silva, Sunto, Brunton, all great compasses, all readily available. Should be at any kind of outdoor store, but certainly, unfortunately, in today's reality, easy to find on the internet, whether that be Amazon or Campmore or backcountry.com or what have you. The compass has kind of been superseded by the handheld GPS. I do have both of them, but I want to let you know that the biggest difference, I think, between these two items is that the GPS requires that you relate with an interface, and the compass requires that you relate with the topography of the landscape and the tool. So I think for the human experience, this is the superior tool. Very convenient, although it's a little freaky to think that this is working off of satellites as well as it's battery powered. This is a cheaper one, still about, I think, $200, $250. And I do use it, but I want to ensure that I never lose the compass, as it is probably more accurate, actually, and it allows for my mind to be relating with my environment as opposed to just an interface. Then there's a lot of stuff on cell phones. I've seen this app OnX, etc. I try to stay up to date as to what new navigational tools are out there. They are really amazing. I'm not going to knock them that way, and they can give us some really valuable information. But if you read the article that I posted, "Is a GPS Scrambling Your Brain?" you'll recognize that they are perhaps allowing for a de-evolution of a part of our brain that I think gives us a larger connection to our landscape and thus ourselves. So this compass does have a sighting mirror on it. That sighting mirror lets me look at what's called a back-azimuth, or where I'm coming from. It also can be used as a signaler or just to shave by. And it has some other neat features that are actually kind of not necessary. The signaling mirror is cool, but it's not necessary. Also has automatic declination, not necessary. I'll explain that in a moment. And a clinometer, which is not necessary. Clinometer has the ability to measure the steepness of slopes, but I use that if I'm mountaineering or backcountry snowboarding where avalanches are concerned. So the other thing that I want to show you is just the common USGS topographical map. Topographical map. These are still common, but we see less of them now. I really like the full-size maps. You can still find them at some stores. You can still buy them online. At one time, they were very common, and just about every general store in Vermont would carry maps of that area. I have quite a collection. It's getting kind of ragtag now. But this in conjunction with your compass, and you're a force to be reckoned with if you know how to use it. But there are other ways to get topographic maps for free. There are programs and apps you can buy, but I recommend CalTopo. CalTopo as in California, CalTopo. And you can get maps of any region in the United States that you're interested in. So let's just kind of go over what the compass is. The compass is working off the magnetic field of the Earth. So as we know, the globe spins, the Earth is spinning. It has both a north and a south pole, North Pole and Antarctica. However, the North and South Pole are not straight up and down, but rather they're on an axis because the Earth is spinning at an axis, so on a slight slant. The inside of the Earth is molten material. Essentially, if we put it in lay terms, it's super, super heated up metals. And those metals, through centrifugal force, are being thrown to the outside of the spinning sphere that is the Earth, and the compass is actually able to pick up on the magnetic fields of the Earth. I got to tell you that pretty much everybody at some point, or many people at some point, were gifted a compass, and then a drunk uncle at Thanksgiving or Christmas tried to show you how to use it. It's not that complicated, but it's one of those things that's been misrepresented for so long that people kind of get this blockage and think that, oh, this is complicated enough for me. That's not the truth. The compass has a bezel, which is this ring, like so, that spins. Just want you to know that that ring spins. There's a lot of numbers and graphs, and they all have awesome purposes, but really your lateral edges of the compass on either side are two different scales, and those scales allow you to measure your distance off of a topographic map pretty easily. Most topographic maps have a scale of 1 to 24,000, and that would correlate with the scale on the compass, which is here, as well as the scale on the map, mostly on the bottom of your map, so you can estimate travel. I'm going to give you a formula for estimating travel. It's pretty easy. It is 1/2 hour per mile of travel plus 1/2 mile per 1,000 feet of elevation gain equals your total travel time. So you have to be able to use that scale to be able to determine the total distance of your travel, and then you have to, you got to have a little comfort with fractions, but at the same time, it's okay to round up and round down. And then you have to know how to read a topographic map. So within a topographic map, we have, this is like 5th grade stuff here, but we have these contour lines. So those contour lines are showing us the topography of the land. In other words, it's showing us the shape of the land, making a one-dimensional map turn into a two-dimensional experience, if you will. So the distance between most contour lines on topographical maps, not all, you have to check the scale of the map, is 20 feet. So each line represents 20 feet of elevation gain or elevation loss. And you can tell this pretty easily by looking at the darker colored contour lines. These are called index lines. And then you'll notice that there'll be a few contour lines and then another index line. And on those index lines, there's a number that shows you the elevation. So you simply subtract one number from the other, then divide it by the number of contour lines you see, and you'll notice that most of the time it's 20 feet. So that's how you're measuring elevation gain. Be careful as you're looking at the maps and ensure that you're looking at a gain and not a decline, because we do not incorporate that that elevation decline into the formula, only incline. And again, it's a rough estimate that happens to work pretty well. So if you're heading for a certain area and you find that you're not there and you anticipated being there, an hour ago, that means you may need to slow down and regroup so that you don't find yourself getting lost. So again, back to the compass, the bezel ring. The bezel ring spins. On the bezel ring, we have our cardinal directions: north, west, south, and east. And in between, there are a number of numbers. The numbers ranging from 0 to 360. Of course, we know 360 is a complete circle. So from any given point on the Earth, you can go 360 different directions. And the compass is going to show you how to do that, or what direction to go. Inside the compass, we notice there's this red floating needle. No matter where I turn that compass, that floating needle is going to point toward magnetic north. Depending on where you are, you will have to do a little bit of math, either adding or subtracting, in order to find true north, because magnetic north does differ from true north. But luckily we have the numerical ability to be able to know what to add and to subtract to find that. So that's just a real introduction to map and compass reading. I think the key parts are understanding what a topographical map is, as well as the difference between a GPS and a compass, and that the compass it's a dynamic tool that does spin, that is pulling off, it has the ability to extrapolate which number or degree you want to go to find a certain area. And then also recognizing that the topographic map shows the shape of the land, and it does so by measuring incremental increases or decreases in elevation, and combined with the map and the compass, we can use them in conjunction to pretty accurately figure out where we're going, and even right down to the point of using that algebraic formula to measure distance. So I hope that was a good introductory lesson. We're gonna launch into how to do that more effectively. Perhaps if I can get you guys to be somewhere in the same ballpark, we can do that synchronously. I hope you're all doing well. I did just get word that next semester we're going to be working hybrid. I'm extremely thrilled, because that means that I get to see my students in person, which is definitely a more valuable experience, I think. And I will see what I can do about doing an in-person experience for all of you in this class, just pro bono. I have no problem doing that, but of course I would like to see some investment beyond what I'm seeing now, to kind of see your stoke, if you will, come up a little bit. Let me know how I'm doing and how I can help you, and hang in there, folks. I'm not really sure how many more classes we have in this course, but I know it's at least a handful. Let's make them great. Thanks for bearing with the tech issues. I can really do nothing about that. I sure have learned a lot, but mostly that when you need technology, that's when it lets you down. All right, take care, everybody. Bye.